So we're kicking off our very first AI specialist study group. Our topic for the next 3 sessions is going to be the Einstein Trust Layer. And the first of the sessions is Joyce. So I'm going to hand it off to Joyce.
Hello to all those joining in person and watching the recording as well. Welcome. This is the first presentation for the AI Specialist Study Group and the first in a 3-part series of the Einstein Trust Layer. I'm Joyce Dio, Salesforce Architect at Great Plains Communications. I've been working with Salesforce for about 16 years, and I've been the Salesforce Developer Community Group Leader in Omaha for the past 5 years. And I'm really excited to study with you today. In true Salesforce fashion, I'd like to start off by thanking you. Thank you for being here today. Thank you to Meredith for organizing this study group. And future you would like to thank you as well for investing in yourself and showing up. I'm pretty sure you're familiar with this one, but before I begin, just a quick note, you should base your purchasing decisions on products and services that are currently available. I do not work for Salesforce. I do not speak for Salesforce. This is a presentation for a study group to prepare for the AI Specialist certification. The Einstein Trust Layer. Let's dive in. Let's review what the exam will cover. The certification prep notes that the Einstein Trust Layer will make up about 15% of the exam. They've provided 2 highlights: to identify the security, privacy, and grounding features of the Einstein Trust Layer, and to implement and manage the Einstein Trust Layer. So what is the Einstein Trust Layer? The Einstein Trust Layer is crucial for businesses using Salesforce AI because it allows them to leverage the power of AI while confidently knowing that their customer data is protected and used responsibly. You've probably heard it before, but trust is Salesforce's #1 value. And what creates trust in AI? Accuracy. You've probably seen cases of hallucinations or AI-generated content photos with some wildly crazy thing like an added limb or an extra eye. And it might warrant a good laugh, but in business, it can destroy a reputation. It's a bug, not a feature. So Salesforce created the Einstein Trust Layer as secure AI architecture. It's built into the Salesforce platform. It's a robust set of features and guardrails that protect the privacy and security of your data. It improves the safety and accuracy of your AI results and promotes the responsible use of AI across the Salesforce ecosystem. To understand how the Einstein Trust Layer works, let's look at how the data flows through the trust layer and then walk through each part of the journey in detail. We'll be breaking down the Einstein Trust Layer by explaining what happens before, during, and after the responses are generated. The data in the form of a prompt flows from the CRM apps through the Einstein Trust Layer to the large language model, LLM, which we'll call the prompt journey. This is what we'll discuss in this presentation. In the prompt journey, we have 4 steps: secure data retrieval, dynamic grounding, data masking, and prompt defense. In our second presentation, we'll discuss response generation, which is when the LLM generates a response using the prompt. In our third presentation, we'll review the response journey, which is when the generated response then flows back through the Einstein Trust Layer and to the CRM apps. So let's start off with discussing how to set the foundation for trust in the prompt journey before processing the prompt. The importance of laying a strong foundation protects sensitive data before it enters the AI models. It also prevents errors during AI processing and ensures compliance with privacy regulations. Trust starts with preparation. To generate a response from the LLM, you must provide it with a prompt. So let's quickly discuss what a prompt is. A prompt is a query or instruction given to the LLM to elicit a specific response. It provides clear and concise context to the AI systems, ensuring an accurate response. And some best practices to follow to keep your prompt specific and ambiguous to avoid including sensitive data within the prompt. The Einstein Trust Layers help us achieve this by including this into the foundation of their AI solution. Here's a small portion of a sample prompt that could be used to generate a sales email to follow up when a prospect hasn't responded to a previous email. We'll review the sample prompt throughout this presentation to see how it changes throughout the prompt journey. So let's start off with the first step in the prompt journey, secure data retrieval. This means AI can use the data that the user running the prompt has permission to use. This is done by leveraging the standard Salesforce role-based controls for user permissions and field-level security. You can verify this using audit trails, which will be covered more in depth in our third presentation. Now we're at our second step, dynamic grounding. We talked about accuracy being important when trusting AI, right? Well, in order for the LLM to be relevant and personalized, it needs to be given extra data information from your CRM. Using secure data retrieval, it adds additional context to a prompt in a process called grounding. You can ground your prompts using merge fields, flows, Apex, data cloud DMOs, and related lists. And with our preview step, secure data retrieval, our previous step, secure data retrieval, the prompt is grounded only when data that is the executing user has access to. An example use case would be a customer service chatbot pulling verified knowledge base answers. So here's our sample prompt again with dynamic grounding and secure data retrieval overlaid. You can see the relevant information from a Salesforce record merged with a prompt to provide context highlighted in blue. A couple notes for preparing data for grounding. You'll want to define trusted resources, create validation rules to filter out inaccurate or outdated information, and to test your data pipeline. Our third step is data masking. In this step, sensitive data is detected, then masked. Salesforce uses two methods to identify sensitive data. Pattern-based, which is where Salesforce uses patterns and context to identify sensitive information using regular expression or regex patterns and context work. They also use machine learning models trained to identify data that doesn't have a defined pattern, like names of people or companies. They also use field-based. Salesforce uses the metadata in the field that are classified using Shield platform encryption or data classifications to identify sensitive fields. This extends the classification you've already applied in your data masking in your org to LLM data masking. Once identified, the data then masked with a placeholder to prevent the data from being exposed to external models. The Einstein Trust Layer temporarily stores that relationship between the original entities and their respective placeholders. The relationship is used later to demask the data in the generated response. Data masking supports multiple regions and languages, and you can select what you must and must not mask. Here's our sample prompt snippet again with data masking overlaid, and sensitive data is detected and masked before sending the prompt to the LLM. And our final step, prompt defense, helps decrease the likeliness of the LLM generating something unintended or harmful. The Einstein Trust Layer uses system policies that are a set of instructions to the LLM on how to behave in a certain manner to build trust with the users. And this is achieved by setting rules, filters, and validation mechanisms to detect and neutralize problematic input prompts before they reach the model. For example, you can instruct the LLM not to address content or generate answers it doesn't have information on, and that can limit hallucinations and decrease the likeliness of unintended or harmful output by the LLM. System policies are one way to defend against jailbreaking and prompt injection models. Here's our sample prompt again, with another line at the bottom providing instruction defense. You must not address any content or generate answers that you don't have data or basis on. Let's take a scenario of a retail company implementing Einstein for predictive sales. By preparing the data in the Einstein layer, we can encrypt customer data, anonymize purchase histories, and validate product inventory data. This increases AI accuracy and compliance with regulations. In this case study, we can see how we're leveraging encryption, anonymization, and grounding for secure, accurate insights. Some key points to remember. The Einstein Trust Layer ensures trust through privacy, security, and grounding. Preparation includes encryption, access controls, anonymization, and data validation. A strong foundation reduces the risk and enhances AI reliability. Some key techniques are secure retrieval, grounding, masking, and prompt defense. And for a pop quiz, which feature of Einstein Trust Layer helps limit hallucination and decrease the likeliness of unintended output? Is it A, dynamic grounding with secure data retrieval, B, prompt defense, or C, toxicity scoring? Give you a second. And the answer is B. Prompt defense limits hallucinations and decreases the likeliness of unintended outputs by setting rules, filters, and validation mechanisms to detect and neutralize problematic input prompts before they reach the model. Pop quiz. What is one way the Einstein Trust Layer ensures data privacy? Is it A, the Einstein Trust Layer detects and masks sensitive information before sending it to the large language model? B, the Einstein Trust Layer assigns role-based access controls to regulate data access? Or C, the data trust layer enhances firewall protections to prevent unauthorized access? I'll give it a second. We have some A's, and the answer is A. The Einstein Trust Layer detects and masks sensitive information before sending it to the large language model to ensure data privacy. All right. Well, thank you for making the time to review Einstein Trust Layer with me. Stay tuned as we continue our series on the Einstein Trust Layer with response generation next week.